Hi, everybody. I'm Sergey Melnikov, and I would like to present you a great talk about observability, talk called Observability Beyond the Three Pillars, Continuous Profiling with Alibaba Dragonwell. And this talk is made by Sanhong Lee. And just before we start talk, I'd like to ask Sanhong, what is your occupation at Alibaba? What are you doing at Alibaba Dragonwell JVM? Why it's so interesting for you?
Okay, thank you, Sergey. And I just gave some brief introduction about myself. And I'm Sanhong. I'm from Alibaba. Actually, in Alibaba, I'm leading the Alibaba Java team, and so far working on the development of Alibaba Dragonwell. Alibaba Dragonwell is a long-term support free OpenJDK distribution made by Alibaba Cloud. I think that's all for my basic information.
So it looks like you're responsible for the whole GM support for Alibaba Cloud. Sounds really great. So I think it's time to start your talk. So I'm really thrilled to listen to what you will be talking about. So floor is yours.
Okay. I think thank you, Sergey. And then it's time for my talk. And I think first of all, I would like to thanks for Joker. It's my honor to be here to talk about this talk. The talk will focus on the observability and how we can do continuous profiling by using Alibaba Dragonwell. Here is the agenda for my talk. And in my talk, actually, I will give you guys some 5 parts in my talk. The first thing is I will go through the basics of observability. Let's go through the definition of observability. And the second part is about, I would like to talk about some fundamental ideas and implementation of Java flat record. And the third part is a major part. I would go through our implementation, how we can implement continuous profiling with Alibaba Dragonwell. And I think the fourth part is a very interesting part. I just prepare some case studies and some demos for you to have a deep understanding about GFR, how we can use GFR to do more deep problem diagnostics. And the final part is a summary. Here is my agenda. Okay, this is the first part. Let's talk about the basics of observability. Actually, the observability was originally coined in 1960, and actually this term is not used for a software system. Actually, after that, actually, the observability has been applied to modern software system, and here is the definition for observability. I just got the reference from this book, Observability Engineering. This is the title, and if you guys have any interesting, you can read it offline. I think for observability, there are 4 characteristics of observability definition. The first is you can use observability to understand the inner workings of your application. The second is you can use observability to understand your system state. And I think the major and more important thing is by relying on observability, actually you can just just relying on external tools to understand either inner workings or system state, and without any shaping new code change. I think this is a very basic definition for observability. Okay, traditionally speaking, actually observability has 3 pillars. You can just look at this picture, and I just got this picture from the CNCF white paper definition. Traditionally, we have three major parts in observability. The first is metrics, which is numerical representation of data measured over time, and the second is trace, and the third is logs. If we understand these concepts from Java perspective, I just give you some example. For example, you can use Java MXB API to acquire or get some your application state. This is generally implemented by some, for example, monitoring application system. And the second is trace. Actually, you can, for example, you can use or rely JVM agent to do some method tracing. For example, you can put some tracing at the beginning of method and at the exit of method, and then you can do some method tracing by using JVM agent. Also, for JVM, actually GC log is a very typical example for logs. This is three observability pillars, and then this is the major concept we would like to talk in today's session, and continuous profiling. Continuous profiling is I think is the fourth aspect of observability. Actually, in 2010, Google pioneered this concept in his paper. I just put the paper name is a continuous profiling infrastructure for data center. I think you can read it offline if you guys have interest in it. And what's a continuous profiling? Actually, it means you can constantly monitor your application performance in real time. I think there are two very important things in continuous profiling. The first thing is for continuous profiling, it will execute in production environment. What does it mean? It means if you want to do some performance profiling, actually you need not any benchmark. You need not any benchmark for products. You can just rely on continuous profiling to do performance tuning. I think this is the first important thing. The second important thing is generally continuous profiling just relying on sampling technology. It's low overhead in production. Okay, let's move on to the conceptual architecture about the continuous profiling. Based on our experience, actually, this slide gives you guys some how we can implement continuous profiling. There are three major parts from left to right. The first part is in your data center. Maybe you run out millions of applications in your data center. Generally, this application would provide some profiling interface. For example, Java, maybe you can use GFR or JVM or some MXB. All things are profiling interface. And in this first step, and we need to implement some collectors and to do data collection. Generally, as I have mentioned in previous slides, and continuous profiling is based on sampling. So we generally just select a random sample of applications for profiling. I think this is the first step for data collection. After data collection, and the data will be stored, and then in step 2, we just need to analyze the collected profiles and then do some aggregation and then store them into the database for query. In step 3, we need a web server. Then the user can use browser to do the query from database. Then in your browser, the system will generate the performance dashboard for you. For example, you can check how much CPU has been consumed and how much memory has been allocated. I think this is a general architecture for continuous profiling implementation. Okay, when we finish the basics of observability, let's go through the fundamentals of Java. Firstly, I would like to give you guys the brief history of Java flight record. And actually, a lot of information. I just give some key moments in Java history. The first thing is Java flight record. Firstly released in JDK 7 as a commercial offering. And then in 2018, it has been open sourced by Oracle in OpenJDK 11. And 2 years later, in 2020, Alibaba is co-working with community and contribute Java back to OpenJDK 8. I think this is some key moments for Java history. And here's the workflow overview from the developer perspective. Tell you guys how we can use Java in your production or in your environment. I think you can look at this picture from left to right, and we just look at this the left picture. Generally, from JVM perspective, JVM has 3 major parts. The first is just-in-time compiler. The second is a garbage collector, and then the remaining part is runtime. And actually, these 3 parts could generate Java events. And how you can enable or how you can control Java. I think Java just provide you guys 3 ways to control Java. The first thing is you can use command line to enable Java. Let's see, for example, you can plus flight record, start flight recording by using command line. This is the first thing. The second way is you can use GCMD command, and for example, you can use Java start and Java stop to enable or stop Java. And then also you can implement it in your Java source code. You can rely on JDK Java API. The API has been shipped since JDK 9, and you can control and enable stop, do some things in your source code. It's very flexible. And another thing is you need to provide some configuration for Java. In this example, the configuration file is called as profile.jfc. After the Java events has been collected and the Java events could be dumped to the disk as a file, as a Java dump file. And when you got the Java dump file, then you have different ways to analyze it. Traditionally, generally, Java developers also generally use Java Mission Console. I think maybe you are familiar with this tool. You can download from the website, from internet, and use Java Mission Console to analyze the Java dump file, and it will show you some cool things in UI, in desktop. And the second thing is you also can use some low overhead command line tools, which tool is the Java tool shipped by JDK distribution. For example, you can use this Java command line to get some summary information about the Java dump file, something like you can check that by your JDK distribution. And the third way is also you can use API to do the analysis. And this API also is released since JDK 9. I think this is a very general workflow introduction for Java. And how we can understand the Java events. And in this slide, just to give you guys the category about Java events. Generally, there are 3 events, 3 kinds of events. The first is we call instant event. It means it occurs immediately. And the second event is we call the duration event. It has a start and end. Also, the third part is a sample event. This event will be logged at a regular interval. I give you guys some example how to understand these GFR events. The example is from this folder. If you got some JDK distribution installed, and you can check this folder, and then you can check this configuration file. In this file, you can say, for example, for instant event, we have thread start. Thread start is an instant event, would be triggered when the thread starts. The second is Java monitor enter. This is a duration or timed event. This event will be triggered when the Java thread enters into Java monitor. And the third example is we called JDK execution example, which is a sample events. Actually, this event is very popular and widely used by in many scenarios, which is used for hot method profiling. Okay, I think this is some basic introduction for GFR, and then we move to next slide, talk about how we can do continuous profiling. Before that, I just give you guys some brief introduction about our product. What's Alibaba Dragonwell? I just talked it earlier in my self introduction. Alibaba Dragonwell is a downstream OpenJDK, free LTS by Alibaba Cloud, and ARMS. ARMS is our, the full name is Application Real-Time Monitoring Service, which is an application performance management service developed by Alibaba Cloud, written in Java. ARMS is running on top of Alibaba Dragonwell. You can just look at this picture. This is the stack. The underline is Alibaba Dragonwell, and ARMS run on top of Alibaba Dragonwell. And as I have mentioned, you know, we need to collect profiling data for your application. We implement the continuous profiler based on GFR and async profiler technology, which is a part of ARMS product. And we just collect profiling data by relying on Java agent. It means for each of our application, we just implement the Java agent and ship it, and we just need to use Java agent to do the collecting profiling data. And the major feature implemented by ARMS are including CPU profiling, allocation profiling, warlock profiling, as well as we do some integration between tracing and profiling. This is something I will discuss you guys in detail. Okay, this is the overview. This is some brief overview about our product for our continuous profiler. And for example, you can set presets. For example, you can set how many times you would like check for your continuous profiling data. And then you can do different profiling. For example, CPU time, allocation, warlock, or lock, different kinds of profiling data. And generally in this area, and it just show you guys the overall profiling data results for your cluster. And also you can do some view filter. For example, you can select one thread, and then it can show you some profiling data for one specific thread, or you can show some profiling data for one specific class. This is general introduction about our feature. And okay, I think many of you guys may be worried about the performance, not the performance, but the overhead. You know, you want to use GFR in production. How much the overhead? How we can access the GFR overhead? Can we use GFR in production? I think this is a big question for our developers. we just access the Java overhead by using JDK 8. This is JDK version, and this is configuration, including OS, CPU, memory, and this is the JVM flags we are using. This is the SpecGBB 2015 benchmark results. When you enable Java, either by using default Java configuration or Java profile configuration, you can say from SpecGBB mark jobs overhead, the overhead is very high. You can say more than 15%. I think from this number is not nice, and I think is not the performance is not acceptable. I think you think you cannot use Java in production, but the good news is you can use this flag, use main bar to minimize the overhead greatly. This is the when you use this flag and when run the benchmark again and recheck the performance overhead, and you can see the overhead is very low, and almost around 2%. I think is very is nice, is good, and we can accept. Actually, for this number, we can use it in our production. And I just would like to explain, give you some reason why we can use this flag to minimize the overhead. And I think the major reason is when without this flag, if you don't use main bar, and the cost were introduced by the call to serialize thread states. For this synchronization mechanism, this mechanism has the performance issue in scalability. So for user main bar, actually this is the flag this is a feature implemented in hotspot. It just uses a direct memory fence operation, which is more cheap to get the state of Java thread. If you guys are interested in the detailed information, would like to figure out why this flag is important for performance optimization, you can follow these two links. I just put the link in my slides, and you can check them and offline and understand more details. Okay. Okay. When we talk about after we talk about the overhead used by Java, let's talk about another important concept: how we can correlate Java with tracing. You can just look at this picture, and for tracing from APM, from performance monitoring perspective, actually tracing is usually recorded by bytecode rewriting. Okay, and actually you need to implement in various types of frameworks used by application for tracing points. So you can just look at this picture. We have different microservice. We have user service, we have item service, and we have order service. We have different microservice. We need to use bytecode rewrite to implement the tracing for all the frameworks used by this or microservice. I think the problem is if some certain framework is not covered, the tracing information will be missed. So that result in some we call them monitoring blind spots. You can just look at this picture. We have order service, and we implement the tracing for order service. We implement it for database path, for cache path, but we miss that. And we also implement the message queue. In these scenarios, actually, we don't know what has happened, what kind of time has been spent in this at this point. So the challenge here is even we have collected Java events at those blind spots, actually we don't know their relationship. Why? The problem is, the reason is currently Java lacks ability to associate the context to Java events. What does it mean? What we want to do? Here's an example what we want to do, how we can correlate the Java to tracing. Before that, I just introduce some basic concept to you. Here, trace is composed of one or more spans. And what's a span? Span in trace context, span is you can just think span is some microservice implemented in some your distributed system. Here example, we have Java thread, we have tracer, we have profiler, then we have one request. We have request one. Then this request will be tracing, and then this request one will be linked to the profiler. Then we do the profiling by using GFR. After that, and we got the request two. During the request two, we also do the same thing and do the continuous profiling. And we got a sample 1 to sample 5. And the key point here is, do you remember the slides? In my previous slides, we have order service. The order service is belonging to span 1003, and we need some correlationship. We need some relationship between span and profiling. We can do this connection. Okay, so that when we have this connection, then we know this sampling, this continuous profiling information is used for span 103. So that after analyzing these results, we got this dashboard, we got this information, profiling information, and the final results, so that we can use these results to detect. We can use these results to detect what has happened at these blind spots. I think this is the key point why we need to do the correlating between tracing and GFR events. As I have mentioned, currently GFR, I remember earlier. Yeah, I just remember here, and the GFR currently don't have ability to associate context to GFR events. So that how we can do that? Here I just give you guys some example at how we can associate the context to GFR. This example actually is based on ideas of async profile and Datadog implementation. And if you have interest, if you want to do more details to have a good understanding how we can do, correlating between GFR and tracing, I just put a link here. You can follow the link to check the more details. In this slide, I just give you some example how we can do the relationship. Okay, so in this slide, you can just look at this picture when your application start up, and we will allocate a fixed memory for thread context storage. And for each of thread, for example, thread 1, we will associate the thread context data for this thread 1. The thread context data will include, for example, trace ID, span ID, or some attribute value. And how can set up this value? You can use Java API, for example, set context to set context by passing trace ID and span ID as a parameter value. And also you can set some attribute value for this context. After that, after the GFR event has been dumped, and for example, for JDK execution sample, this is a GFR event, and it has a normal fields. For example, start time, event thread, and after this GFR event has been dumped, and we will append this additional context information, including tracing ID, span ID, or attribute into this GFR event, so that when we analyze the GFR dump file and we got this GFR event, then we know we will know the additional context information, for example, trace ID and span ID. I think this is a general or example introduction about how we can associate the context for Java event. Okay, this is a lesson learned we got. The first thing is if you are running on top of JDK 8, if your number of Java threads is very large, for example, more than 500, CPU overhead may be expensive. And this is the picture. You can see when the number of threads is getting large and the CPU overhead is very high. So as I have mentioned, for this case, if you are running on Java 8, JDK 8, it's very highly recommend you to use main bar flag to avoid this problem. This is the lesson 1. And lesson 2, if you want to do the memory allocation profiling, the problem here is if you are running on top of JDK 8 or JDK 11, the amount of events for memory allocation profiling may be large. If your application if your application has a very fast memory allocation, we don't recommend you to enable it. I think this is a problem. You will got a performance issue. This is the information. You can check this OpenJDK bug. And for the lesson 3, if you want to use this event for this event name is old object sample. If you want to use this event for example, for detecting object leakage, then if you are using JDK before 11.07 and it has a problem, it may cause Java file to be very large. So this problem, and you can check the detailed information by following this debugger ID. And also the const is if you before JDK 11.0.12, this event cost is very expensive, also not suitable for production. In summary, if you want to use old object sample, and we do recommend you to use the latest JDK 11 version. Okay, let's go to the first part. I prepare some demos. Before that, I give you some background information. This is the metrics I captured from our real workloads running in Alibaba Cloud. The first is CPU, and the second is young GC count per 10 minutes. You can see along with time going, and the CPU consumption is very stable. But for young GC count, and you can see the change is turbulent. And I just mark the big change in rectangle. In the worst case, we will got 200 young GC count per 10 minutes. So the cost is very high. So if you check the GC log, actually GC log cannot tell you what allocated the most objects. Okay, so how can we do that? So this is a case study. In hotspot just to support object allocation profiling by providing these 2 events. The first is event object allocation outside TLab. Another is in TLab. And generally, TLab is a mechanism implementing hotspot for fast allocation. Each thread has its own TLab buffer, so it's very cheap for allocation. Anyway, we can use these 2 events for object allocation profiling. Here's an example. And for example, this is a picture I got from Java mission control result. We have 3 rows. Each row represents 1 thread. And for each thread, actually, you can check how much memory has been allocated outside TLab, or how much memory has been allocated in TLab. Okay, let's go to my demo. This is my demo. Actually, I will run server. The server will make object allocation when the request arrived. And After that, I will launch GCMD to enable Java for object allocation profiling. After that, I will launch a client to send request to server. When request has been handled, I will use these tools, JMCX. I will give you guys some introduction about this tool to generate folded stacks from Java dump file. After that, we can use a popular flame graph tool to generate a flame graph. This is general workflow for my demo. Okay. Before run server, I saw this is a script for launching server. You can see I using GTK 11, and I just set G1 GC for my GC configuration. Okay. Let me launch the server. Okay. When the server launched, and here I just figure out which is my server process. Here is the process ID, and then we enable Java by setting correct process ID. Okay, then I just use this allocate profile configuration file. What's that? I just show you in my configuration file. I just enable these two important Java events. As I have mentioned, one is allocation in new TLab, and another is allocation outside TLab. Okay, let us enable Java. Okay, after that, I just launch client to send a request to the server. Oh, sorry. Oh, got a problem. Okay. I need to relaunch the server. Okay, let me relaunch my server. Let me check which my server. Here. I just enable Java. Okay, the Java has been enabled. After that, I just launch my client to send a request. When the server got a request, it will be handled. I will show you the code implemented in my server. When the request arrived, the load map function will be called. In this function, it just reads the contents from the file on disk, then just do some string split. After that, just put the results into the map. It's very simple and straightforward. Okay, when the request is handled, and I just need to stop the Java. Let's check process again. My server, then I stop the Java. Then we just save the Java dump here. Okay, after stop, the dump file will be written here. This is JFR dump file. After this, other JFR dump file is dumped, then we do some analyzing here. And after that, I just need to analyze this JFR dump file. I use this command line. I just give you some explain these tools. This tool has been developed by Alibaba internally. We are planning to open source in later. Actually, from your guys' perspective, I think you can also implement these tools by yourself, or you can analyze this JFR dump file by using Java mission control. If you want to implement it by yourself, as I have mentioned, OpenJDK has provided some Java API, the JFR API for analyzing the JFR dump file. Actually, you can follow the JFR API guide and implement your tools by yourself. Here, I just use my internal tools, and I just specify the dump file. And this is dump file, and this is the event we would like to analyze. Allocation TLAP. Okay. After that. Okay. Okay. So after the analyzing this dump file, the collects the stack data will be generated here. We can use this as an input to generate a flame graph. Is a flame graph, and we can generate a flame graph. Okay, and I just prepare the results here. Okay, you can check this flame graph, and you can check this stack, and you can check in line 32 load map, 32 load map, 32 here. Okay, you can see Spring Split has allocated more objects. Okay, 32, and you can see Spring Split has allocated most of objects here. So for it, by using this flame graph, you can just optimize your application to minimize the object allocation used by Spring Split. If, for example, you can, if you have time and you can do more experiments, you can replace Spring Split with some Spring substring and to optimize these results. Okay, this is my first demo. Go back to my slides. Go to the second demo. Second demo is talk about how can capture the de-optimization results. As maybe if you are familiar with the hotspot or JVM technology, you know the de-optimization concept. When something is when the assumption is wrong, and the hotspot will fail to interpreter, and the cost is very high. So because the speculation is wrong, so the code need to fall back to interpreter and wait for recompilation. I think the cost is very expensive. I just give you guys the unstable if case. For example, just look at this code. We have two branch A and branch B. And the hotspot is very smart. They can rely on branch profiling. They can rely on branch profiling information to detect the branch A is a hot path and the branch B is a cold path. After that, then they just will, the hotspot will put the branch B into what we call the uncommon trap, this code will not be compiled, and when this path is taken, it will be trapped into runtime. The cost is very high. So let me show you the Java demo for the optimization. This is general overview. We need to run JMH benchmark, and then again, I just use this to generate folded stacks from Java dump file. Then we can check the frame graph. Here, let me run. Here, and you can say I enable Java by command line, and just use the configuration here, and I just configuration here, the optimization here. Okay, in my configuration, I just enable the optimization event, and then I just run the benchmark. Need some time to complete. Okay, I just show my source code. In my source code, you can say I just implement the hot method, and in this hot method, I just implement the manual else if case, and in this case, actually, it will cause many unstable if de-optimization. And again, just the same things I did in the previous demo. We can just use GCMX tool to generate folder stacks and generate frame graph. I just show the final results here. I just prepare before demo. This one, okay. Here's the de-optimization frame graph for my demo. You can see lot of de-optimization happened at line 41 and 41. I show demo 41. Okay, happen here, and then following this stack, you can see 23 and 25 and 27. A lot of happen optimization, de-optimization. Let me check. 23, 25, 27. Okay. This is just a quick demo for how can we use Java event, de-optimization event to capture the cost of de-optimization. Okay, let me go back to my demo. This is my second demo, and okay. Here's my all contents of my talk, and generally go through give you some summary. I give you the definition of observability, and also go through basics of continuous profiling. Also share you guys the basics of Java, how that look like for Java workflow, how to use it, and what look like Java events. Give you guys some example. And in third part, I just give you some Alibaba practice and share some lesson learned when we implement the continuous profiler. In last part, I just give you guys two case studies for object allocation profiling and de-optimization profiling. I think that's all for my talk, and thanks for your attention.
So I think we run out of our time slot, so it's time to go to discussion zone. So feel free to join us at discussion zone, and we will discuss all questions. As far as I see, we have at least one question, so
okay,
let's go.
Thanks.